Hi, welcome to New Tech YouTube channel. In this video, we are going to study and solve example on mesh or loop analysis. Let's start. Mesh or loop analysis is used in network or circuit theory to obtain mesh or loop currents using KVL and Ohm's law. If you are interested to study KVL, then separate video of the same is available on the YouTube channel, or I will give you link of the same in the description. Now see some key definitions. First one, what is a mesh? It's loop which does not contain inner loop. And what is a node? Statement, a point at which two or more elements have a common connection is called a node. These key definitions are very useful in understanding of mesh or loop analysis. After studying key definitions, let's see a representation of mesh or loop using simple electric circuit. It consists of one voltage source V1 and four resistors R1, R2 and R3 and R4. Those are arranged in such a way that to form a two mesh or loops as mesh 1 and mesh 2, denoted by currents I1 and I2 in clockwise direction, which is shown in the diagram. We just studied a representation of mesh or loop. Let's begin with the procedure of mesh or loop analysis. Procedure point 1, identify the total number of meshes or loops. Point 2, assign the mesh currents. Point 3, develop the KVL equation for each mesh or loop. Point 4, solve KVL equations for the mesh currents. Using procedure of mesh or loop analysis, we are going to solve example on the same example statement. Using mesh or loop analysis, find currents I1 and I2 using the diagram shown. Let's write given data. Voltage source Vs is equal to 45 volt. Resistor R1 is equal to 10 ohm, R2 is equal to 20 ohm, R3 is equal to 30 ohm and resistor R4 is equal to 40 ohm. Now refer given data and write KVL equation for mesh 1. Before that, let's see the diagram. Current I1 passes through resistor R1 and R2 in clockwise direction, which produces potential V1 and V2 across resistor R1 and R2. And current I2 also passes through resistor R2 in clockwise direction, produces potential V2 across resistor R2. Now mark the voltage polarities as per current entering into the resistors, either plus or minus. Using previously studied mesh analysis theory, write KVL equation for mesh 1 as voltage source Vs minus voltage V1 across resistor R1 minus voltage V2 across resistor R2 is equal to 0, which is represented by equation 1, where voltage V1 is equal to current I1 into resistor R1 and voltage V2 is equal to current I1 into resistor R2 minus current I2 into resistor R2. Now substitute values of voltage V1 and V2 into equation 1 as Vs minus I1 into R1 minus current I1 into R2 minus current I2 into R2 is equal to 0 as shown in the equation 2. Now using given data, value of voltage source Vs is equal to 45 volt, resistor R1 is equal to 10 ohm and resistor R2 is equal to 20 ohm. Then equation 2 becomes 45 volt minus I1 into 10 ohm minus I1 into 20 ohm plus I2 into 20 ohm is equal to 0. Rearrange the common terms. 45 volt minus I1 into 30 ohm plus I2 into 20 ohm, which is equal to 0. Then equation 3 represented as I1 into 30 ohm minus I2 into 20 ohm is equal to 45 volt. Again, write KVL for mesh 2 as. Before that, let's see the diagram. Current I2 passes through resistor R2, R3 and R4 in clockwise direction, which produces potentials V2, V3 and V4 respectively, and current I1 also passes through resistor R2 in clockwise direction and produces potential V2. Write KVL equation for mesh 2 as minus V2 minus V3 minus V4 is equal to 0, represented by equation 4, where voltage V2 is equal to I2 into R2 minus I1 into R2. Voltage V3 is equal to I2 into R3 and voltage V4 is equal to I2 into R4. Substitute values of V2, V3 and V4 into equation 4, we get following equation as minus current I2 into R2 minus current I1 into R2 minus current I2 into R3 minus current I2 into R4 is equal to 0. Let's substitute values of R2, R3 and R4 into previously studied equation as minus I2 into 20 ohm plus I1 into 20 ohm minus I2 into 30 ohm minus I2 into 40 ohm is equal to 0. After simplification and rearrangement of common terms, we get equation as current I1 into 20 ohm minus current I2 into 90 ohm is equal to 0, which is represented by equation 5. Now let's solve equation which is obtained by using mesh 1 and equation 5 which is obtained by using mesh 2 by determinant method. Here determinant D is called as coefficient determinant, represented as first row represents coefficient of equation 3 as 30 and minus 20, and second row represents coefficient of equation 5 as 20 and minus 90. After solving the same, we get coefficient determinant D is equal to minus 2300. Then find determinant di1 as replace the values of column in determinant D, which is represented as 30 and 20, with values of constant of equation 3 and 5 as 45 and 0. After calculation, we get di1 is equal to minus 4050. Then find determinant di2 as replace the values of column in determinant D, which is represented as minus 20 and minus 90, with values of constant of equation 3 and 5 as 45 and 0. After calculation, we get di2 is equal to minus 900. Now find values of mesh currents I1 and I2 as current I1 is equal to determinant di1 divided by determinant D, which is equal to minus 4050 divided by minus 2300, which is equal to 1.760 ampere, and current I2 is equal to determinant di2 divided by determinant D, which is equal to minus 900 divided by minus 2300, which is equal to 0.391 ampere. We obtained mesh currents values I1 is equal to 1.760 ampere and I2 is equal to 0.391 ampere by solving equation 3 of mesh 1 and equation 5 of mesh 2. Here we have verified our previously calculated results using Multisim software, which also gives the same values of mesh currents I1 and I2 as a 1.761 ampere and 391.305 milliampere, which is equivalent to 0.391 ampere. Hence, we have verified the same using a Multisim software. In this video, we have studied theory and solved example on mesh or loop analysis. Thanks for watching my YouTube channel. Thank you.